Good morning, students. Welcome back to chemistry class. Today we are going to study about hydrogen peroxide. Hydrogen peroxide H2O2 and preparation and their physical properties and chemical properties. That's all today we are going to study. Okay. First upon, we are going to study about how can you prepare hydrogen peroxide. Preparation of hydrogen peroxide. Okay, hydrogen peroxide means hydrogen H2O2. Per means 2. Okay, per means 2. So hydrogen peroxide means H2O2. Okay, so how can you prepare hydrogen peroxide? It can be prepared by treating metal peroxide with dilute acid. It can be prepared by treating metal peroxide with dilute acid. Okay, metal peroxide means metal. You know about the metal: sodium, magnesium, beryllium, barium, calcium, strontium, rubidium, alkali metals, and first group and second group in the periodic table. First group elements and second group elements we called as the metals. Okay, metals. Okay, so metal peroxide, for example, barium oxide. Okay, barium is one of the metal, and O2 means oxide. Okay, peroxide 2. How much oxygen? Having 2 oxygen. So barium peroxide, it is treated with the dilute acid. We are taking one of the acid here, sulfuric acid. When barium dioxide, barium peroxide, it is treated with the dilute sulfuric acid, we get the hydrogen and oxygen. Hydrogen in sulfuric acid and oxygen in metal peroxide, it combined to form the H2O2. Hydrogen peroxide. What is the remaining product here? Barium combines with the sulfate to form barium sulfate precipitate. Okay, when barium dioxide or barium peroxide treated with the dilute sulfuric acid, the hydrogen and oxygen, okay, combined to form the hydrogen peroxide, and barium and sulfate combined to form the barium sulfate precipitate. Understood? Another one example, metal peroxide, we are taking sodium peroxide, Na2O2, sodium peroxide, Na2O2. Okay, why here barium peroxide BaO2, but sodium only Na2O2, because the balance of the electrons. Okay, sodium, sodium is the monovalent, barium divalent. Okay, so oxygen atom need 2 electron. Okay, so sodium atom we should take 2 sodium atom. Okay, so sodium peroxide when treated with the dilute sulfuric acid H2SO4, it forms when barium and the hydrogen in sulfuric acid and oxygen in sodium peroxide, we get the H2O2. And what is the remaining product here? Sodium Na2 and sulfate, sodium sulfate, Na2SO4. Okay, this is the laboratory preparation of hydrogen peroxide. Okay. On an industrial scale means large scale. How can you prepare the hydrogen peroxide in large scale? Okay, here we are taking auto-oxidation of 2-alkyl anthraquinol. Okay, so how can you prepare hydrogen peroxide large scale? These two reactions, it is the laboratory preparation. We cannot prepare large scale. Okay, hydrogen peroxide we can prepare large scale by the auto-oxidation of 2-alkyl anthraquinol. 2-alkyl anthraquinol. Okay, so what do you mean by auto-oxidation? Auto-oxidation means spontaneous oxidation of compound in the presence of air. Auto-oxidation means spontaneous oxidation of compound in the presence of air. Okay, so How can you prepare hydrogen peroxide in industrial scale? Auto oxidation or 2-alkyl anthraquinol. Anthraquinol to one of the compound. Anthraquinol. Okay, how can you write the anthraquinol formula? Anthraquinol, we get hydrolysis of anthraquinone. Okay, anthraquinol, how will you get the anthraquinol? Hydrolysis of 2-alkyl anthraquinone. When hydrolysis of 2-alkyl anthraquinone, we get the 2-alkyl anthraquinol. Okay, what is the structure of 2-alkyl anthraquinone and what is the structure of 2-alkyl anthraquinol? Okay, listen here. Before you are drawing the structure of 2-ethyl anthraquinone, you should understand what do you mean by how can you draw the structure of benzene. How can you draw the structure of benzene ring? This is very important, very important. All of you should understand how can you draw the structure of benzene. What is the formula for the benzene? Means C6H6. C6H6. This is the formula for benzene. So the structure of benzene means this is the structure of benzene. Okay. So each corner of this ring having the carbon atoms, carbon, and each carbon atom is connected with the hydrogen. This is the structure of benzene ring. Okay, C6H6. Understood? So here you should remember the carbon atom, carbon valency 4. What is the valency of carbon? 4. So carbon atom should surrounded by 4 bonds. Okay. See here this carbon surrounded by how much bonds? 1, 2, 3, 4. And this carbon surrounded by 1, 2, 3, 4. 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 Okay. So this is the structure of benzene ring. Okay, so how can you draw the structure of quinone? This is the structure of benzene. So quinone means, how can you draw the quinone means? Here this is the structure of benzene. When benzene ring means within the ring having the alternate double bond. This is the benzene ring. Okay, but here this is the one of the ring. This is not benzene ring because it here not having any double bond. Okay, so what is the name of this compound? Cyclohexane. What do you mean by cyclohexane? Hexane means totally how many carbon atoms having? 6. 1, 2, 3, 4, 5, 6. Totally 6 carbon atoms having. So it is called as hexane. So this ring we mentioned as the cyclohexane. Okay, so cyclohexane means carbon valency 4. So each carbon should surrounded by 4 bonds. Here each carbon surrounded by only 2 bonds. This carbon surrounded by only 2 bonds. This and this 2. This carbon 1. This and this. This carbon this and this. This carbon this and. So each carbon should surround with 4 bonds. So each carbon having the 2 hydrogen atom. Each carbon atom connected with the 2 hydrogen atom. Okay. Now each carbon atom gets the 4 valency. This carbon 1, 2, 3, 4. This carbon 1, 2, 3, 4. This carbon 1, 2, 3, 4. Okay. So all the carbon atom gets the 4 valency. Okay, so this, what is the name of this compound? Cyclohexane. Okay, so quinone means the 2 carbon atoms connected with the all the carbon atom connected with the 2 hydrogen atom. Okay, each carbon atom connected with the 2 hydrogen atom. But here this carbon and this carbon, this 2 hydrogen atom, instead of this 2 hydrogen atom, it forms it forms, it bonded with the oxygen atom. It bonded with the oxygen atom. Double bond. These two H2 leave out when, but these two bond are having here. So this carbon double bond oxygen here, the carbon double bond oxygen. These two hydrogen atom leave out. Okay, so this is called quinone. What is the name of this compound? This is the quinone. Okay, cyclohexane with two oxygen atom, that is called quinone. This is the quinone. So anthraquinone, 2 alkyl anthraquinone means here this is the quinone, and in quinone ring it is connected with the 2 benzene ring. Okay, connected with the 2 benzene ring. Benzene ring means C6H6. Okay, so inside the ring having the alternate double bond. Alternate double bond. This is the anthraquinone. What is the name of this compound? Anthraquinone. Anthraquinone. Okay, so here to prepare the hydrogen peroxide, we need 2-alkyl anthraquinone or 2-ethyl anthraquinone. 2 means here we mentioned this is the first carbon. So this is the second carbon. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, this is the number of carbon atoms here. 2 means this is the second position, second carbon atom. So this position, alkyl group is connected here, C2H5. C2H5. Instead of this hydrogen present in the carbon atom, one of the ethyl group is connected here, C2H5. Okay, so what is the name of this compound now? 2-ethyl anthraquinone. Okay, or 2-alkyl anthraquinone. Alkyl group means methyl, ethyl, propyl, butyl, pentyl, hexyl, heptyl. This group are alkyl groups. Okay. For example, one carbon atom, only one carbon atom and 3 hydrogen atom. This is the methyl. 1 carbon, 2 carbon and 5 hydrogen means ethyl. 3 carbon and 7 hydrogen means propyl. Okay, 4 carbon and 9 hydrogen we called butyl, and 5 carbon means pentyl, 6 carbon means hexyl. Okay, this so commonly we called as the alkyl group. These all groups we commonly called as the alkyl group. Any group, maybe methyl, maybe ethyl, maybe propyl, maybe butyl, maybe pentyl. Okay, all groups commonly we called as the alkyl group. So 2-alkyl anthraquinone, or which alkyl group present here? Ethyl group, C2H5. So ethyl group, so we are called as the 2-ethyl anthraquinone. Understood about the structure of 2-ethyl anthraquinone? And then this 2-ethyl anthraquinone, when reduced with the hydrogen H2, okay, hydrogen act as the catalyst here. Now these 2 hydrogen atom, it is combined with the quinone compound. So we get this double bond, it is converted to the single bond. This bond, it bonded with this hydrogen atom, and this oxygen atom, this double bond, it is converted to single bond, and this bond is it bonded with this another one hydrogen atom, OH. So we get the here, this is the compound, first bond, this is the quinone. Instead of quinone, here one of the here double bond having one of the bond, and one bond is bonded with the hydrogen from here, and another one hydrogen bonded with this double bond converted to single bond, and one of the bond it bonded with this hydrogen atom. Okay, and 2-ethyl anthraquinone compound, C2H5. Okay, so here what is the name of this compound? Now this name 2-ethyl anthraquinol. Okay, quinol, NOL. Okay, this is anthraquinone. because of the double bond and oxygen CO group coming here. Okay, CO group means CO means ketone group, ketone. Okay, this is organic chemistry. You will study in your second volume book having the organic chemistry, chemical organic chemistry, naming of the organic compounds. You will study. Okay, so double bond oxygen, double bond and oxygen, carbon. This is carbon, double bond oxygen means ketone group. Ketone group we called as the one, end with one, androquinone. This OH group means alcohol group. Okay, alcohol. OH means alcohol group. So we called as the 2-ethyl anthraquinol. OL. Understood? Alcohol end with OL. OH means alcohol. When alcohol group it end when naming this alcohol group it end with the OL. Ketone group means ONE. Understood? So what is the name of this compound? So how can you prepare the hydrogen peroxide? When first upon 2-ethyl anthraquinone, it a reduction with hydrogen, the presence of hydrogen is the catalyst, we get the 2-ethyl anthraquinol. Okay, and this anthraquinol, it undergoes auto-oxidation. What do you mean by auto-oxidation? Continuous oxidation in the presence of air, O2. Spontaneous, continuous, okay, continuous oxidation with air. So these two oxygen atom it is combined here. So we get this two oxygen atom combined with this this hydrogen to form hydrogen peroxide, H2O2. Okay, now we are studying about the preparation of hydrogen peroxide. Okay, so one of the compound 2-ethyl anthraquinone, when reduction with hydrogen as the catalyst, we get the 2-ethyl anthraquinol, and this 2-ethyl anthraquinol, it undergoes auto-oxidation, we get the hydrogen peroxide. And what is the remaining product here? The reactant also, we get the product here. What is the reactant? First reactant 2-ethyl anthraquinone. So here by auto-oxidation of 2-ethyl anthraquinol, when removing the hydrogen atom present in the 2-ethyl anthraquinol, we get the hydrogen peroxide, and also we get the reactant. First reactant we get as the product. Okay, 2-ethyl anthraquinone. 2-ethyl anthraquinol we get as the product. Okay, when we this hydrogen peroxide, this compound, these two compounds, we are hydrolysis means adding water to this compound, we get two layers. Okay, first layer, that is the organic layer. Organic layer means this compound. Which compound? 2-ethyl anthraquinone. 2-ethyl anthraquinone is the first layer. That is the organic layer. Okay, when we are mixing the water with oil, it floating. Okay, it is the first layer, and water, it is the bottom having the water. Okay, so like that here when we are mixing this organic compound, that is hydrogen peroxide and 2-ethyl anthraquinone, we are mixing with the water, that separate layer having there, the first layer we called as the organic layer, and the final the bottom layer we called as the hydrogen peroxide. Okay, so in this layer 40% of the solution of hydrogen peroxide are having. 40% solution of hydrogen peroxides are having in this layer. Okay, understood? This is the preparation of hydrogen peroxide. And then what are the physical properties of hydrogen peroxide? What are the physical properties of hydrogen peroxide? The pure hydrogen peroxide, it is the colorless liquid. Okay, pure hydrogen peroxide is colorless liquid, that is pale blue color. Okay, pale blue means light blue. Okay, it consider the colorless. Okay, and colorless liquid and less volatile. What do you mean by volatile? Means volatile, when we are water we are boiling the hydrogen and oxygen, it is highly vaporized. Okay, it is evaporated as vapor. Okay, that is called volatile. But hydrogen peroxide is less volatile. Okay, this is the second property. A third property, it more viscous than water. More viscous than water. Why? What do you mean by viscous? Viscous means water. When we are taking water and oil, for example, when we are taking water and oil, when we are leaving the water molecule in ground, when we are leaving the water molecule, it fastly moving. Okay, fastly moving. But in oil, another one vessel, we are taking oil. When we are leaving the oil out, the oil is slowly moving. Okay, water is fastly moving, but oil is slowly moving. Okay, like that. Hydrogen peroxide, it is more viscous. Okay, because the way the oil, it is moving slowly, because it is more viscous than water. Water is fastly moving. When we are pouring out, water is fastly moving when compared to the oil, because oil is more viscous. Okay, the molecules of oil is tightly bound. Okay, but molecules of water, it is loosely bound, so it is a low viscosity water. Okay, like that, hydrogen peroxide, it is more viscous than water, more viscous. Understood about the viscous means? Okay. And another one physical property having, what is the another one physical property? When we are sealing the hydrogen peroxide in chemical marketing, it is sale as the 100 volume, but only 30% solution of hydrogen peroxide is there. Okay, only 30% of hydrogen peroxide solution, it is marketed as 100 volume hydrogen peroxide. 100 volume. Okay, it indicates the STP. In STP means standard temperature and pressure. Standard temperature, pressure means 0 degree Celsius temperature and 1 atmospheric pressure. The hydrogen peroxide sailing as the 100 volume, but only 30% of hydrogen peroxide is there. Okay, it means when 100 ml of the oxygen in the hydrogen peroxide is liberated by 1 ml of this solution on heating. Okay, why this is marketed as 100 volume? Only 30% hydrogen peroxide marketed as 100 volume, because when we are heating 1 ml of this solution means 100 volume hydrogen peroxide. When 1 ml we are taking and heating this 1 ml of hydrogen peroxide, it will leave out, it will liberated 100 ml of oxygen. Okay, because of this, the 30% hydrogen peroxide we are marketed as 100 volume. Understood? Okay, these are about the physical properties of hydrogen peroxide. Okay, students, how the hydrogen peroxide acts both as oxidizing agent and reducing agent. Now I am going to explain with an example. Okay, so first upon, in acidic medium. Okay, in acidic medium, I am taking one of the acidic medium means H2O2. When it reacts, reacts with the hydrogen H plus, that is the acidic medium. Okay, H2O2, when it combines with the H plus and 2 electron, we get H2O. Okay, here how many hydrogen? 2 hydrogen and 2 oxygen. 2 hydrogen and 2 oxygen, but here only 1 oxygen, so we have to make here 2. Okay, so 2 hydrogen, and here also 2 hydrogen, 2 2s are 4 hydrogen, and it combines with the 2 oxygen, we get the water. Okay, so this is the acidic medium. It is in acidic medium. Okay, here two electron, these two H plus ion accept these two electrons. Okay, accept these two electron. It form the water molecule. Here the hydrogen peroxide, it acts as the oxidizing agent. Oxidizing agent. Okay, oxidizing agent means hydrogen peroxide acts as the oxidizing agent means it oxidizes the hydrogen. Okay, it oxidizes the hydrogen. So here two electron, having these two electron given by this hydrogen peroxide for this hydrogen atom. Okay, understood? So in acidic medium, hydrogen peroxide acts as the oxidizing agent. Oxidizing agent. Okay, now we are studying about the both oxidizing and the reducing property of hydrogen peroxide. Both oxidizing and reducing property of hydrogen peroxide. Okay, whichever property we are studying, both oxidizing and reducing property of hydrogen peroxide. Oxidizing property means it can give the electron to the other elements. Okay, so the hydrogen peroxide of the substance, it can give electron to the other substance. That means oxidizing agent. Reducing both, and reducing agent means hydrogen peroxide also acts as the reducing agent. Reducing agent means it can gain electron. Okay, it can gain electron from any other substance. Okay, that is the reducing agent. Okay, and I hope all of you understood about the oxidizing agent and the reducing agent. Okay, and you should understand what do you mean by oxidation and what do you mean by reduction. What do you mean by oxidation and what do you mean by reduction? Okay, according to electronic concept, oxidation means loss of electron. Oxidation means loss of electrons. Okay, reduction means gain of electrons. Reduction means gain of electrons. In your lower classes you study, maybe you are studied about the oxidation or reduction. That is, oxidation means addition of oxygen and removal of hydrogen. Reduction means addition of hydrogen and removal of hydrogen. Okay, I'm not telling about that concept. There are different concepts having there about the oxidation and reduction. Okay, so here we are studying about the electronic concept. Okay, it related to the electrons. Here relating only electrons. Okay, so according to electronic concept, oxidation means loss of electron, reduction means gain of electrons. Okay, so for this reaction, which one takes place here? Addition of electrons or removal of electron, loss of electron or gain of electron takes place here? Gain of electron takes place here. Two hydrogen atom, it gain two electrons. It adds up two electron to form to reduce to the water molecule. Okay, so to hydrogen peroxide to reduce the water molecule, the hydrogen atom should hydrogen atom added here. These two hydrogen atom, hydrogen ion, it can gain electron. Gaining electron takes place for this reaction. Okay, so gaining of electron means what is the reaction here? Reduction. So in acidic medium, which reaction takes place? A reduction reaction takes place. Okay, here hydrogen peroxide, it is act as the oxidizing agent. Oxidizing agent and oxidation, these are two different concepts. Oxidizing agent means one of the substance can lose electrons. That is called the oxidizing agent. But oxidation means loss of electron. Okay, oxidizing agent means one of the substance can donate electrons, can can give electrons to the other elements or other ions. Okay, so that is called oxidizing agent. But oxidation means loss of electron. Oxidation means one of the reaction. Oxidizing agent means one of the substance. Telling about the one of the substance. Okay, here hydrogen peroxide is act as the oxidizing agent. It can give electron to the hydrogen ions. Okay, understood? So this is the acidic medium. So in acidic medium, hydrogen peroxide acts as the reducing agent. So oxidizing agent. So which types of reaction takes place here? Reduction reaction. Because in this reaction, gaining of electron takes place. Okay, electrons are gaining of electron takes place here. So this reaction is called a reduction. Understood? So reduction means, what do you mean by reduction reaction? Gain of electron means reduction. So in acidic medium, which type of reaction takes place? A reduction reaction. But in your textbook, differently having. Okay. And for the example for this reaction, when ferrous sulfate, FeSO4, ferrous sulfate, what is the formula for ferrous sulfate? FeSO4. Okay, FeSO4. And it in acidic medium means sulfuric acid is added here. Sulfuric acid, it reacts with the ferrous sulfate and hydrogen peroxide here. A reaction with ferrous sulfate, sulfuric acid and hydrogen peroxide. Here, the ferrous sulfate is converted to ferric sulfate. Ferrous sulfate is converted to ferric sulfate. FeSO4 is converted to Fe2SO4 thrice. Okay, Fe2SO4 thrice. Okay, so here the hydrogen peroxide, it reduced to water molecule, H2O. Here hydrogen peroxide give 2 electrons to the ferrous sulfate to form the ferric. Okay, understood? So here, so FeSO4 plus H2SO4 plus H2O2 gives Fe2SO4 thrice. Fe2SO4 thrice. Okay, plus 2H2O. How can this reaction is balanced here? How many Fe having here? Only one having, but here 2 is Fe having. So we have to make here 2. Now sulfate, how many sulfate molecules are having? Here 2 and 1. So totally 3 sulfates are having. Equation is balanced here. Hydrogen, how many hydrogen? Here 2, here 2. So we have to make here 2. So 2H2. Oxygen, how much oxygen? 2 oxygen. So here also 2 oxygen. This is the acidic condition reaction. Okay. And in basic condition, the hydrogen peroxide with basic condition means OH minus. This is one of the base, OH minus is the base. And when it combines with the hydrogen peroxide, here only one hydrogen, monohydrogen peroxide, OH minus, and when only one hydrogen we are taking, so minus, HO2 minus means one electron. So the H plus only leave out. So this electron is having here. So when OH minus is combines with the monohydric dioxide to form oxygen and water. Here 2 electrons are lost. Okay, so hydrogen here, the hydrogen peroxide lost this 2 electron. Okay, OH minus, that is base, it lost 2 electron. Okay, understood? So in basic medium means OH minus, base means OH minus, acid means H plus. Okay, when we are adding acid means that is the acidic medium. When we are adding base means that is the basic medium. In basic medium, which type of reaction takes place here? Oxidation. In acidic medium, which type of reaction takes place? Reduction, because there the gaining of electron takes place. But in the basic medium, oxidation takes place because here loss of electron takes place. Okay, loss of electron means oxidation. Understood? And what is the potential? Okay, this is the potential difference having here for the acidic medium. E0 value is equal to plus 1.77 volt. 1.77 volt electric potential is developed here when the reduction reaction and the oxidation reaction plus 0.08 volt electrical potential is developed. Plus 0.08 volt electrical potential is developed. Okay, so for the basic media, for example, the KMNO4, okay, KMNO4 when reacts with the hydrogen peroxide, KMNO4, potassium permanganate react with the hydrogen peroxide, both it is an aqueous solution. So we get the potassium permanganate is converted to manganese dioxide, MnO2, and the potassium it is combined with the oxygen is in the hydrogen peroxide to form KOH, and water, the hydrogen it is converted to water, H2O, and this oxygen is MnO4, it leave out the oxygen gas. Okay, so we have to balance the equation now. Here how much potassium atom? Here only one potassium, here also only one potassium. Potassium is balanced. Manganese, here only one manganese, here also only one manganese. Manganese also balanced now. Hydrogen here, 2 hydrogen, but here 2 1, here 1 plus 2 3 hydrogen having here, but here only 2, so we have to make here 2. Okay, now 4 hydrogen having, but here only 3 plus 1 2 hydrogen only, 3 plus 1 3 hydrogen only having, so we have to make here 2. So now hydrogen is balanced, but potassium is not balanced. Potassium only 1 potassium here 2, so we have to make here 2. Now potassium and potassium balanced, but manganese here only 1 manganese only having, so we have to make here 2. Now potassium balanced, manganese balanced, hydrogen also balanced. Hydrogen here 2 2s are 4. Here also 2 plus 2 4. Okay, oxygen 4 2s are 8. 8 plus 2 8 plus 2 4 2s are 8. 8 plus 4 12 oxygen atom. Okay, 2 2s are 4. 8 plus 4 12 oxygen atom having, but here 2 2s are 4. 2 2s are 4. 4 plus 2 6. 6 plus 1 7. 7 plus 2 9 oxygen only having here. So we have to make here 2. Okay, we can make here 2. Now 2 2s are 4. 4 plus 2 6. 6 plus 1 7. 7 plus 4 11 oxygen. Here 12. So not balanced now. So we have to make here 3. Okay, 3 means 2 2s are 4. 4 plus 2 6. 6 plus 1 7. 7 plus 3 2s are 6 means 7 plus 6 means 13 oxygen. But here how much oxygen having? 4 2s are 8. 8 plus 12. 8 plus 4 12 oxygen only having. So we have to make here 3. Okay, here we have to make here 3. Now oxygen, how much oxygen having here? 4 2s are 8. 3 to 6. So 8 plus 6 14 oxygen. But here 2 2s are 4. 4 plus 2 6. 6 plus 2 8. 8 plus 6. Okay, 2 2s are 4. 4 plus 2 6. 6 plus 1 7. 7 plus 6 13. Only 13. Okay, so I have to make here 2. 2 means now oxygen balanced. Okay, 2 2s are 4. 4 plus 2 6. 6 plus 2 8. 8 plus 6. 3 to 6 means 14. Oxygen balanced. Now hydrogen balanced or not? Hydrogen, how much hydrogen here? 3 2s are 6 hydrogen. Here 2 plus 2 2s are 4. 4 plus 2, 6. Hydrogen also balanced. Everything now balanced. Okay, understood? So this is the hydrogen peroxide in basic condition. Understood? This is very, very important. So today's assignment, state hydrogen peroxide acts both as oxidizing agent and reducing agent. Okay, very, very important question. If you are having book, take your book now. In your book, page number 112, 112, take now. The hydrogen peroxide, the second paragraph onwards, so to mark. Hydrogen peroxide can act both as oxidizing agent and a reducing agent. Oxidation is usually performed in acidic medium, while the reduction reaction is performed in basic. This is wrong. The oxidation is usually performed in basic medium. Okay, basic medium, and the reduction reaction performed in acidic medium. Okay, and then what is the acidic medium? What is the reaction? H2O2 plus 2H plus 2E minus gives 2H2O. Okay, what is the electric potential developed here? E0 is equal to plus 1.77 volt. For example, FeSO4 ferrous sulfate plus H2SO4 in acidic medium, it reacts with the hydrogen peroxide. We get the Fe2SO4 thrice. Okay, Fe2SO4 thrice. This is called the ferric sulfate. Okay, plus 2H2O. And in basic medium, HO2 minus plus OH minus gives O2 plus H2O plus 2E minus. Okay, so here what is the potential difference takes place? E0 is equal to plus 0.08 volt. For example, KMnO4, 2 KMnO4 in aqueous solution plus 3H2O plus in aqueous solution, we get 2 MnO2 plus 2 KOH plus 2 H2O plus 3O2 in gas. Okay, very, very important. You should study and write the assignment and send me through my WhatsApp number. Thank you, students. Thank you.